form as low pressure centers over warm bodies of water such as oceans. The warm water allows air to rise, and that moisture from the ocean evaporates, creating those clouds, those thunderstorm clouds. And the low pressure is what gives the hurricanes that spin. As the hurricanes spin and remain over the warm bodies of water longer, the stronger and the bigger they get. That's why hurricanes are huge. They can span over a couple miles. Tornadoes form from a storm called supercells. These storms are created from a rotating warm updraft, and they also create the cool downdrafts. With the cold air and the warm air rotating, that's how supercells are able to create tornadoes. Now, if hurricanes and tornadoes were to collide, well, they don't exactly do that, but hurricanes can create tornadoes.
When there's a large amount of rainfall that falls in a short amount of time, the ground can have a hard time absorbing the water. It all depends on what the ground is made of and if it is already full of water. Sand, for example, can absorb more water than clay. When there is nowhere for the water to go, it can pool or run off. The water can end up in different places. It can slowly absorb into the ground, flow to a drain, or even end up in a larger body of water like a lake or a river.
Snow is soft because it's made out of tiny light ice crystals that stick together gently, creating snowflakes and also just kind of collected snowflake clumps, if you've ever seen that, floating down from the sky. As for hail, I believe Amanda explained that it's formed by tiny ice crystals, debris, or even raindrops just getting continuously circled through the upper parts of the storm system, freezing over and over until eventually it falls down due to gravity. And thus, that is why snow is much softer than hail. So hail comes in all kinds of shapes and sizes. The most common type of hail is obviously the kind that is spherical, and it just falls in tiny little balls and you really don't think much of it. Now, when hail is being created, as I referenced and as Amanda referenced, sometimes it has a lot of time to kind of accumulate to other pieces of hail, as well as debris. And sometimes this allows us to see for pretty cool crystals, such as there was one with like a ladybug in it, or other times they'll be like jagged and stuff. So yeah, that's how hail gets its shape. So, as you guys know, rain is a very important part to the water cycle. And if we didn't have rain, chances are we probably wouldn't have water at all. Because rain is just kind of like a process that happens during the water cycle. And thus, it wouldn't happen if we didn't have water. Now, if we didn't have rain, most plants and animals would die. It would be very hard to cultivate food without water. Water is basically the basis of all life here on Earth. And so if it didn't rain, it would be very hot and very hard to live.
During the winter months, temperatures in Mesa typically stay above freezing, especially during the day. For snow to form, temperatures need to be below freezing, 32 degrees Fahrenheit or 0 degrees Celsius, for extended periods of time. And this is more common in higher elevation areas or locations further up north. In Mesa, while nighttime temperatures can occasionally dip near freezing, daytime highs usually stay well above freezing, preventing snow from accumulating. However, Mesa has seen snow on Superstition Mountains, but it is rare. This is due to the elevation changes and temperature differences.
It gets colder when it rains for a few different reasons. When it is raining, there are clouds. Clouds can help block the sun's rays from continuing to heat the surface. There is also a barrier from direct sunlight on us. Another reason is that water can hold more heat than dry air. If there is moisture in the air, it is absorbing some of the heat that we would feel.
Yes, Generally, the atmosphere decreases in temperature as you increase in height. However, there can be little variations in temperature throughout. So if snow forms at below freezing temperatures high in the atmosphere and then falls through a warmer layer below, it might melt into rain. But then if it falls through another colder layer below, it could refreeze into something called sleet or potentially freezing rain, which is a very dangerous weather phenomenon. Hail often coexists with rain. We get hail with severe thunderstorms even during the height of summer in Arizona when surface temperatures are over 110 degrees because hail grows in the cold updraft of the cumulonimbus cloud. When that hail gets heavy enough that it falls to Earth, it falls faster than it can melt due to gravity. To forecast the weather, the National Weather Service starts with data from weather stations, satellites, aircraft observations, and weather balloons. This data is then fed through computer models that simulate the atmosphere and how it flows and changes through time. This is done using a large number of complex mathematical equations that solve for variables like pressure, temperature, humidity, and wind speed and direction. These models are run for every surface location across the United States and even the world, as well as for different levels of the atmosphere. Unfortunately, given how complex these equations are and how dynamic the atmosphere is, it's impossible to accurately forecast the exact future temperature or rainfall amount for a location. There are many different weather models with their own strengths and weaknesses, but if lots of models are showing the same forecast, meteorologists can feel more confident in their predictions. It is still up to forecasters to evaluate the accuracy of these models and adjust if needed. Water is technically a renewable resource because it is replenished through the natural processes of the water cycle. Water turns into water vapor by evaporating from oceans, lakes, and rivers or being extracted from plants by transpiration. That water is then condensed into clouds and precipitates out through rain or snow. Water can then run off back into bodies of water, soak into the ground and replenish groundwater, or become stored in glaciers and ice caps. Then the cycle can begin again. However, there is only a finite amount of fresh water resources available, so whether that water remains available is up to us to live sustainably.
Knowing the weather helps you to be prepared and safe as you enter the real world. More importantly, it helps you stay safe. You know, if you know what the weather is going to be like and you know that there is a severe weather warning or alert, you have time to get prepared and find shelter. On a more minor scale, you have time to dress appropriately and plan your weekend plans according to that information.
So dark clouds usually indicate a thunderstorm, a cumulonimbus cloud, just in general precipitating water. A cloud will get darker as it's more full of water. It's harder for the sunlight to reach all the way down through this thick cloud. Like Amanda said, that could have a strong updraft full of hail and ice crystals. You have all this stuff in a cloud. The sun isn't gonna go right through it like it does with you have your nice cumulus cloud. That's why it appears darker. The equation of state is a fundamental atmospheric principle that relates temperature, density, and pressure. So as you go up in the atmosphere, the pressure decreases, temperature decreases, and your density, your particles get more spread out. So what this allows for is heat to be lost because there is less containment of this heat. And you're losing heat as you go up in the atmosphere. Imagine you're standing at the surface. You have the entire atmosphere above your head. But let's say you move 2,000 feet up, you have 2,000 feet less of the atmosphere that you had at the surface on top of your head than you did before. So when you're on top of a mountain, even though you're technically closer to the sun, you're not going to feel warmer temperatures because there's no air up there. There is air, but there's not much air.
Clouds form from air rising and reaching a point in the atmosphere, or a temperature in the atmosphere, where it becomes wet or saturated. Yes, lightning does come from clouds. They come from a cloud called cumulonimbus. These clouds are those thunderstorm clouds that you see off in the distance, super big, super puffy, and they give you all our thunderstorm, our rainstorms, all of the fun stuff, right? So with these types of clouds, you'll have negative charges in the bottom of the cloud and positive charges more near the top of the cloud or on the ground. The negative and the positive charges, they want to connect. What we see as lightning is the positive and negative charges connecting. So our lightning bolts that we see are going to be the negative charges in the bottom of the cloud connecting with the positive charges on the ground. When we're seeing those flashes of light within the cloud, that's the negative charges from the bottom of the cloud going through to the top of the cloud where those other positive charges are.